In this video, we'll be going over the molality homework, page 427, numbers 27 and 28. Number 27 says, determine the number of grams of solute needed to make the following molal solutions. We did question A. Question A says a 4.5 molal solution of H2SO4 in 1 kilogram of water. So we need to remember that molality with a little m equals the moles of solute, which in this case is H2SO4. Remember, we name solutions based on the solute, so if it's a solution of H2SO4, that is the solute. And since it's in water, water is our solvent, and it's per kilogram of solvent, so kilogram of water. So we know the molality, that's the little m down here. We know the kilograms of water. We can calculate the moles. It wants the number of grams of solute. So we can do it based on the equation, in which case we multiply each side by kilograms of water. We get moles sulfuric acid equals molality times the mass of water in kilograms, which is 4.50 molal, or mole per kilogram, times 1.00 kilogram of water. Kilograms cancel, and we get 4.50 moles of H2SO4. From there, we take 4.5 mole of H2SO4, and we convert it to grams using our molar mass. So we calculate molar mass. We take the mass of hydrogen times 2 plus the mass of sulfur plus the mass of oxygen times 4. We get 98.09 grams per 1 mole. Moles cancel. I multiply my molar mass by the number of moles I have, and I get an answer of 441.405 grams sulfuric acid. My starting values were both 3 significant figures, so I'm going to only take 3 significant figures here, so I'm going to have 441 grams of H2SO4. That's using the equation. The other way I could have done this problem, I could have done this problem doing only conversion factors. To do it that way, I would start with what I know that's not a conversion factor, which would be my 1.0 kilogram water, because molality I can convert to moles of solute, H2SO4, per 1 kilogram of the solvent, which is water. So I'll come down here with my 1 kilogram of water, 1.00 kilogram H2O. I put kilograms on the bottom to cancel, mole on top, the H2SO4, because I'm going to put molality here, which is 4.50 moles per 1 kilogram of water. Kilograms cancel. And then I use the molar mass. Mole to grams H2SO4. Get 1 mole, 98.09 grams, and I get 441 grams H2SO4 is my answer. Either way of solving this problem will work. Question 28 says a solution is prepared by dissolving 17.1 grams of sucrose, C12H22O11, in 275 grams of water. What is the molar mass of sucrose is the first question. So we take carbon, which is 12.01 grams per mole, times the subscript 12 plus hydrogen 1.01 grams per mole times the 22 plus oxygen 16.00 grams per mole times the 11 subscript. Calculate that out. Carbon times 12 plus hydrogen times 22 plus oxygen times 11, and I get 342.34. 342.34 grams per mole. So that's A. B wants to know the molality of the solution. So we take molality equals mole of solute, which is sucrose, per kilogram mass of water in kilograms of water. Now we're given grams of water and we're given grams of sucrose, but we're not given moles or kilograms. Now the way we determined which was the solute and which was the solvent, again, was based on what's dissolved in what. We had sucrose in water. Since sucrose is dissolved, it's dissolving in water, sucrose must be the solute if it's being dissolved. In water means water is the solvent. The thing that dissolves other things is the solvent. So we need to take sucrose, is 17.1 gram sucrose, change it to moles. So I put gram on the bottom, mole on top. And this is where I put my molar mass. So I had 342.34 grams per 1 mole. Calculate that. 17.1 divided by 342.34, and I get 0.04995 mole of sucrose. Grams had canceled. And I need to get my water in kilograms. So 275 grams of water, go from grams to kilograms. There's 1,000 grams per 1 kilogram. So I divide that by 1,000, I'll get 0.275 kilograms of water. Now I plug these values in my equation up here. Moles on top, 0.04995 moles sucrose over 0.275 kilograms of water. So I have my moles of sucrose that I already have calculated here. I'm going to divide by 0.275. And the answer I get is 0.1816. Again, I look at my numbers I had before. I have 3 significant figures in both, so my answer can only have 3. So I get 0.182. 0.182 moles per kilogram is molal, little m, sucrose solution. And there's my answer. This is the end of the discussion on molality. This is the end of the discussion on molality.